So let's continue from where we stopped. Okay, so we stopped at Boolean errors, right? So let's continue. Boolean arrays. So let's define same like we defined the days, right? So at the start, we define this, right? So let's define this and convert that into an array, right? So so you converted this into array. Okay. So let's create a Boolean array uh, in p.array. Let's convert that also into array. Let's define some true false, arbitrary true and false of length same as days. False, true, 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 false. Okay, true, false, true, 1, 2, 3, 4, 5, 6, 7. Okay, so you define an Boolean array. Let's run this. Now let's filter out from the days array. Okay, so I'm defining days. I'm filtering the Boolean array, like days array using the Boolean array. Okay, so I'm sending Boolean array into this days array. Sorry, days array. Okay, so Boolean array into days. Okay. See, first is true. Monday is true. That all, see here what it means is all truths will be displayed. All false won't be displayed. So Tuesday won't be, it's false. Wednesday is displayed, it's true. Thursday is true. Friday is false. Saturday is false, and Sunday is true. So only all truths are displayed. So that's how we interpret this. Mm. And let's go to another example, arrange. So we have defined arrange already. We arrange. Let's take a range of 10 numbers starting from 0 to 9. Let's display the result. Okay, so 0 to 9. Now let's again do some bool operation here. I just want um, those which satisfy arrange comma 2 underscore 2 is greater than 5. So which all numbers are greater than 5, that I want to show. Okay, and I am printing this bool arr underscore 2. Let's check the result once. See, first till this point all will be like this condition will fail, so all will be false till this point. From this onwards it will be true, right? So true, 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 true. So we can perform this simple numerical operations. So let's come to other numerical operations. So we have defined already arrange 1, right? So it's a number consists array list consists from 0 to 4. Now let's perform other numerical operations. Let's add something to this arrange underscore 1 plus 3. Let's add some number and see the check. So it adds directly to every element in the array. Check also other multiplication once, some number 2 with that, so it directly multiplies with each element in the array. Now we can compare. Okay, so first for the comparison, let's define array 1 is equal to in p dot, I'm calling the array function, So I'm defining 1, 3, 4, 6 and array 2 np dot array. I'm defining 5, 3, 8, 6. Okay, 5, 3, 8, 6. Okay, so two arrays I'm defining here, 1, 3, 4, 6 and 5, 3, 8, 6. Let's check whether they are equal or not. So for that we have to do double equal, right? So equal array underscore 2. Whether we array 1 equals to array 2 or not, we are checking. Okay, just check. So first, see how it performs is, see here there are 4 elements in each array. So first element is compared with the first element of the second row. First element of the first array is compared with the first element of the second array. So 1 is 1 equal to 5? No, false. Is 3 equal to 3? Yes, true. Is 4 equal to 8? No, false. Is 6 equal to yes, true. Okay, this is how it works. Now let's check another operation, whether array 1 is less than or equal to array 2. How does it work? Just check. See, again it performs corresponding to each element. Suppose first is compared with the first. 1 less than 5? Yes. 3 less than 3? No. It is equal to 3, right? It's not less than 3. 4 less than 8? Yes. 6 less than 6? No, false. Okay. Now let's go to sum. We can perform sum also. Okay. So array, I'm defining array underscore sum is equal to np dot array. I'm defining from 0 to 1, 0 to 5, sorry, 0, 1, 2, 3, 4, 5. 5 elements I'm defining, sorry, 6 elements. I'm invoking a function called sum, np dot sum, and I'm sending this as input, this variable, this array sum as input. Okay, so let's check the result. So 15, it adds all the elements. So 0 plus 1 plus 2 plus 3 plus 4 plus 5. Okay, since it's a one dimension, it adds all the elements. And also we can invoke in other way also some function. Just call this first array name. Array name is array underscore sum dot. Just call the method sum. Just check the result. Let's display in the other line. Otherwise, it won't get printed. We did not use print function, right? Okay, this is 15 and this is also 15. Okay, two ways we can invoke the sum function. Let's check the sum in 2D, 2 dimensions. Okay, so again you have to define an array with 2 dimensions and underscore sum. I'm defining a variable array underscore sum underscore 2 is equal to np dot array. I'm defining a list 0, 1, 2, 3, 4, 5. Sorry. 0, 1, 2 is as one list and another list as 3, 4, 5. Okay, so I'm defining two lists, and again that should be closed by square brackets. Okay, I'm defining two lists and creating a bigger list and converting that into an array. Now let's see the result once. Dot sum underscore 2. Okay, so this is a 2-dimensional array. Now let's call sum function. Now how does it perform? Very important. Okay, so see, it's adding all the elements irrespective. See, though it is two dimension, it's adding. If you don't specify any constraint, it's adding all the elements in the list. So again, see 0, 1, 2. Again, it's adding to this list 3, 4, 5. So it is again creating a 15. Suppose if you want to create only the row sum or column sum, then we have to give the input. So how do we give input? So suppose if you want to create a column sum, column wise sum, column wise column wise. Okay, so axis is equal to, so for column wise sum you have to give axis as 0. Let's check this. So okay, this is okay. So here what axis is equal to 0 is sum occurs across the column. So this is the first column, 0 and 3 is the first column, 1, 4 is second column, 2, 5 is the third column. So for this, along this first sum occurs. 0 plus 3 is 3, 1 plus 4 is 5, and 2 plus 5 is 7. So 3, 5, 7 is displayed. If you want a row wise sum, then we have to give axis is equal to 1. Okay, so this axis is 0 and 1 are very handy, so you should know about this. So see, two rows, this is row 1, this is row 2, I mean 0th index and first index. So it performs sum across this. 0 plus 1 plus 2 is 3, and second is 3 plus 4 plus 5 is 12. So this is how it works, so row wise and column wise sum. And we have a function called minimum. Let's define that also. Array np dot array five, 6, 3, 9, 7. So I'm defining an array and I want to get the minimum element in this array. So array dot minimum, just directly you can call this. Okay, the minimum element is 3. So you have max also. You can invoke max. Like just change min into max. Okay, 9. And then we have function called min and arg max. So basically arg means it gives the what is first, it finds the what is the minimum element, what is the minimum of this list or array. First it finds the minimum of this array, and then it finds the index of that minimum. arg min is that. Same way arg max also, first it finds the maximum of maximum element, and then finds the index of that maximum element. Okay, so just try calling the same array dot arg min. So what is the index of 3 here? Since it starts with 0, 0th index is 5, first index is 6, second index is 3, so index is 2. Same way, check array dot arg max. So what is the index of maximum element? 3, 9, right? 0, 1, 2, 3, 3. Okay. Now let's go to let's perform some statistical operations. Statistical operations. So what are some statistical operations? We have mean, we have median, we have standard deviation. So these three are very common statistical operations we can have. So let's define an array for that. AR is equal to np.array. So you should get habituated with this all np.array and how we put brackets and all. So that you need not refer anything. So directly you can type and do it. Yes, 12, 15, 24, 13, 17, 21, 23. So I have defined an array. I'm performing array dot mean. So we have mean function. So two ways we can invoke this function. Okay, this should be inside the hash, right? So okay, so this is mean gives 17.85. So two ways we can invoke the mean. We can invoke directly the function mean, whereas we can invoke it from numpy. So numpy np dot mean and pass the array. This also we can invoke. Okay, so both are same. Let's do median. So what is median? np dot median. This is how we invoke median and pass the AR. Median gives 17. Check standard deviation std, and we have a function called std AR dot std. Both ways we can print here dot std at the same time np dot std by sending AR. Both mean the same. Okay, but also we have we can reshape also. We have a function called reshape. I'll explain what is reshape with the example. Array is equal to np dot array 0, 1, 2, 3, 4, 5, defining an array till 5. Okay, so first let's display the result so that you will understand what reshape is. So I'm reshaping this array. So dot reshape. For reshape you have to give syntax like this, 2, 3. Okay, so let's try this AR dot 2, 3 and assigning it to. So let's call this. What is the result? You check once. See, this is a one-dimensional array. Now I want an array with 2 dimensions and 3 columns, 2 rows and 3 columns. So how does it do? 0, 1, 2 and 3, 4, 5. So 2 rows are created and 3 columns are created. Okay, so this is a reshape. But also we can do sort. What is sort? Like we can do as from minimum to maximum or max to minimum. Okay, so for that let's define an array np.array. Sorry, 12, 15, 24, 13, 17, 21, 23. Okay, we have defined an array. Let's sort it. Sort again we have to invoke it from numpy sort and send the input as this array. Okay, so 12, 13, 15, 17, 21, 23, 24. It got sorted, right? Suppose this is a one-dimensional array. How does sort happen in 2 dimensions? that also will check array dot two array underscore 2 and p dot array p dot array. So again let's define two dimensions, 374 again comma 563. Okay, so this is the first first dimension, this is the second dimension, and again three columns are there, two rows and three columns. Now just display the result. How does it look? Now sort it once, perform sort in p dot sort. Okay, so just sort. See again, since we did not pass any constraints, again it sorts all the elements. Sorry, it is array 2, right? We are passing the same. Okay. Okay, so here a sort works like first it does sort on first row, see 374, 347, and again it comes to second row and does the sort. See, basically this happens row wise sort. Default is row wise sort. Suppose you want column wise sort, as we discussed, you have to give axis as you have to give the axis here. So sort AR axis is equal to 1. Let's give the axis and check. Sorry, AR2, right? See, 347, 356. If axis is equal to 1, then it performs row wise. And it is also, if you don't give also, it performs row wise. But if you give axis as 0 and check, see, it performs column 3 5 6 7 3 4, 3 5 6 7 3 4. So axis is equal to 0 is column wise, axis is equal to 1 is row wise. Anyhow, axis is equal to 1 is need not be mentioned because this sort always performs row wise. So this is what Numpy. So I've covered most of the important operations and all. So this notebook also will be shared with you so that you can check. Okay, so that's it with the Numpy.